Hello YouTube, this video is part of a demonstration that's really meant to be interactive, and you can see the interactive version of it by going to this web page. Okay, you want to see the non-interactive version? Here we go. Hepatitis is a very nasty liver disease that is caused by a bunch of different viruses. These ones are hepatitis A and hepatitis B, and they look pretty similar to one another. However, here are two other viruses. These are polio and yellow fever, and they look much more close to hepatitis A than hepatitis B did. And then on the other hand, here are two viruses that have the exact same number of proteins and the exact same layout of proteins that you get on hepatitis B. Now, hepatitis A and B do have a relationship to one another. In fact, all of these viruses have a relationship to one another. You've just got to be looking very closely at their patterns in order to see it. We want to do that, and so the first step is to simplify the patterns. And that means staring at this thing until you have convinced yourself that it looks like hepatitis A. Now you might actually recognize this pattern because it is the exact same layout of pentagons and hexagons that you get on this football, or soccer ball if you are American. Now, we're not specifically interested in this pattern. We want to see its connection to other virus patterns, and so we want to cut it open and lay it flat, because that allows us to see the whole thing at once. And it also allows us to see that hepatitis A's pattern fits into a much larger and more recognizable pattern. And now we have something that I'd like you to try modifying. Now let's say that we specifically make this thing this size and this orientation, because now if we wrap it back up again, we are at something that looks a heck of a lot like hepatitis B. And if we go back to the model, unwrap it again, make it smaller again, wrap it back up again, we're now at hepatitis A. And in fact, there are thousands and thousands more viruses that can be made with some variation on the size of this shape. And so, try playing around with it a bit more and using this button. Try playing around with it a bit more and using this button. Now the reason that viruses use these patterns is because they're sort of like a bigger version of this thing. Now this thing was made out of pentagons, but these viruses have pentagons and hexagons. And that's simply because you can shake this around with a few hexagons in there and you will get bigger patterns. It's impossible, by the way, to make a spherical pattern with just hexagons. The viruses always need to have a few pentagons in there, and if you play around with the model a bit more, you'll be able to see how the pentagons come out of the hexagons. And if you feel like challenging yourself, here's a virus that you can try constructing. Now these patterns are generally very, very simple to assemble, which is why there are a huge number of human designs that make use of them in some way. One of the more famous examples is buildings like this one, which is at Disneyland, and for my money it looks quite a lot like this virus, which is one of the largest viruses that we know about. Now that building was designed by this guy, Richard Buckminster Fuller, although he would always have told you that he was inspired by earlier sources, like this traditional Thai basket weave and this African hairstyle. Now here's a beautiful coincidence. Buckminster Fuller was working at about the first time that microscopes became good enough that they could work on viruses. And so, with Buckminster Fuller's works appearing in lots of magazines, the patterns that appeared on these viruses were instantly recognised. And so, long story short, a bunch of biologists got in touch with him, and this model, the first virus model, emerged as a collaboration between architecture and biology. Now you can choose the next virus that you're interested in.